Hello everyone, welcome to Physics Teacher. In this video, I am going to demonstrate a lab that I do with my grade 12 chemistry students, where we analyze the different colors of flames and then look at the energy of those photons that will be released. There's a simple chart. This is the lab handout I give my students. If you want a copy of it, you can download it for free in the handouts. So the first metal ion we're going to be testing is sodium. So this is a really nice bright orange flame. And so we're going to have to figure out the wavelength, frequency, and energy. So let's do this first one together, and then you can do the other ones on your own.
All right, let's start by estimating the wavelength. So here is the spectrum for visible light, wavelength listed in nanometers. Now this is a guess, it really is. But it was like an orangey color. So let's go with about here, maybe 620 nanometers. Let's do that. So our wavelength is going to be 620 nanometers. Okay, and 1 nanometer is 10 to the minus 9. So 1 nanometer is 10 to the negative 9 meters. So we can use this to convert our wavelength into meters. So it's 620 times 10 to the minus 9, or in scientific notation, 6.20 times 10 to the minus 7 meters. All right, and we have two equations that are going to help us. First, to figure out frequency, we have our universal wave equation, which is the speed of the wave, which is the speed of light, c, is equal to its frequency times its wavelength. So rearranging for frequency, we get frequency is c over lambda. And c, being the speed of light, is a constant, so that is 3.00 times 10 to the 8 meters per second, divided by what we have for lambda here, 6.20 times 10 to the minus 7 meters. And you can see that's going to give us units of per second, which is our units for frequency. And we get 4.84 times 10 to the power of 14 per second, okay, which is also known as hertz. All right, now that we have frequency, we can figure out the energy of that photon. So the energy of the photon is going to be equal to Planck's constant times the frequency. All right, so we have Planck's constant as 6.63 times 10 to the minus 34 joule seconds, times by that frequency, 4.84 times 10 to the 14 per second. So you can see our per seconds are going to cancel. We get units of energy, which is joules. And we get an energy of 3.21 times 10 to the minus 19 joules. So that's how we do our calculations.
Okay, the next metal ion we're testing is copper. See, we're starting to get a really nice blue color there. Okay, so you can do the calculations on that one on your own. Next metal ion is strontium. There's a beautiful red. Okay, I'll let you estimate the wavelength and then make the calculations for the energy of those photons. Lastly, we have barium. And that's a beautiful yellowish orange color. I'll let you guess the wavelength or make an approximation for the wavelength and do the calculations. All right, I hope you enjoyed that. If you haven't subscribed already, please do so, leave a like, and if you have any questions, let me know in the comments.